Hi everyone, this is Ms. Shea. In this video we will be looking at the nuclear atom. After watching this video, you will be able to describe the location of protons, neutrons, and electrons in the atom, and deduce from nuclear symbol notations the number of protons, neutrons, and electrons in atoms, isotopes, and ions. The atom is the smallest unit of an element. From the works of many scientists throughout history, we now have an understanding of the composition of the atom. In the center of the atom is the nucleus. It is made up of protons and neutrons, which are collectively known as the nucleons. Almost all of the atom's mass is concentrated in the nucleus. Because of this, the nucleus is very dense. Outside of the nucleus is the electron cloud. This is the area where electrons are found. The electron cloud is mostly empty space, and almost all of the atom's volume is occupied by the electron cloud. The protons, neutrons, and electrons are the subatomic particles. The proton is symbolized with a lowercase p. Its relative mass is 1 AMU, and it has a positive charge. The neutron is symbolized with a lowercase n. Its relative mass is 1 AMU, and it is neutral, meaning it has no charge. Because the protons and neutrons are both in the nucleus, but the protons have a positive charge while the neutrons have no charge, the nucleus is positively charged. And finally, the electron is symbolized with a lowercase e. Its mass is 1,836 times smaller than the mass of the protons and neutrons, or 5.45 times 10 to the negative 4 AMU, which is so small that it is negligible. So we often say that the electron has no mass. While it has negligible mass, the electron has a negative charge. Here we see a box from the periodic table. Specifically, this is the box for the element magnesium. The whole number on the top, 12 in this case, is the atomic number. The letter that takes up most of the box, in this case Mg, is the atomic symbol. And the number with decimals, 24.305 for magnesium, is the relative atomic mass. The atomic number symbolized by the letter Z is the number of protons in the nucleus. Because protons are positive and electrons are negative, the atomic number is also equal to the number of electrons in a neutral atom. The mass number symbolized by the letter A is the number of protons plus the number of neutrons. It is important to note that the mass number and the relative atomic mass are not the same thing. In the case of magnesium, its relative atomic mass is 24.305, but its mass number is 24. We often write the atomic number, mass number, and atomic symbol in a nuclear symbol notation. The atomic number Z is written as a subscript on the left of the atomic symbol, and the mass number A is written as a superscript on the left of the symbol. From the nuclear symbol notation, we can figure out the number of protons, neutrons, and electrons in an atom. For example, the aluminum atom has a mass number of 27 and an atomic number of 13. So it has 13 protons, 14 neutrons, and 13 electrons. The chlorine atom has a mass number of 25 and an atomic number of 17. So it has 17 protons, 18 neutrons, and 17 electrons. Ions are formed when atoms gain or lose electrons. Because electrons have a negative charge, gaining or losing electrons will result in a charge. A cation is a positively charged ion that is formed when an atom loses electrons. For example, a sodium ion is formed when the neutral sodium atom loses one electron, forming a positive 1 charge. An anion is a negatively charged ion that is formed when an atom gains electrons. For example, a chloride ion is formed when the neutral chlorine atom gains 1 electron, forming a negative 1 charge. The aluminum ion has a positive 3 charge with a mass number of 27 and an atomic number of 13. It has 13 protons and 14 neutrons. If it is neutral, then it would have 13 electrons, but because it has a positive 3 charge, we know that it has lost 3 electrons, and so it has 10 electrons. The oxide ion has a negative 2 charge, with a mass number of 16 and an atomic number of 8. It has 8 protons and 8 neutrons. If it is neutral, it would have 8 electrons, but because it has a negative 2 charge, we know that it has gained 2 electrons, and so it has 10 electrons. Atoms of the same element with different numbers of neutrons are called isotopes. Because neutrons have no charge but have mass, isotopes have different mass numbers. For example, this picture shows you 3 common isotopes of carbon. Carbon has an atomic number of 6, so all 3 isotopes have 6 protons. Carbon-12 has 6 neutrons, which makes its mass number 12. Carbon-13 has 7 neutrons with a mass number of 13. And carbon-14 has 8 neutrons with a mass number of 14. It is important to note that isotopes of the same element have the same chemical properties but have slightly different physical properties.